All right, guys, welcome to the second part of the 1.2 video notes. So these are the last couple problems here. We've got 5 problems to go through, so hopefully this video doesn't take too long. So again, this is solving multi-step equations. Like I said last time, it always helps us to start by simplifying the problem as much as you can. So it's the same thing here that we did before in the first video, right? I can go ahead and distribute this through. So I have negative 3x plus 4x 4 times minus 4 times 2 is 8, minus 8 equals 15. Okay. Equals 15. Same thing, can I combine the like terms? This negative 3x and this 4x can combine to make 1x or just x. Okay. Minus 8 equals 15. Add 8 on both sides to isolate the variable. Trying to get x alone. These cancel out. X equals 23. Again, you can plug that back in to verify. Same thing on the next one, right? Distribute. Now be careful here when you distribute. I've got a negative 2 that's being distributed. So I'm going to distribute the negative through everything. So I have 6x. And I'm distributing a negative 2 to everything inside. So I got negative 2 times x, which is a negative 2x. And I have a negative 2 times negative 5, which is a positive 10, right? 2 negatives make a positive. So now you got something like this. 6x and negative 2x, they combine to make 4x's. Let's isolate the variables, subtract 10. These cancel out. 4x equals 36. Again, whenever you can't see an operation, if there's just 4 next to an x, this means 4 times x. Divide by 4. Divide by 4. X equals 9. Moving down. So these next couple of problems you can do 2 different ways. And so I'm going to show you the way that I like, but I mean, you can do it either way. But I'll show you the way that I like, and I'll show you, I might show you both ways actually. That might actually help a lot. So the first way I'm going to show you is that I can either, let me tell you what 2 ways are. I can either distribute the 3/5 to everything, right? So that's one thing you could do. You could go in here and just go 3/5 times 2x, 3/5 times negative 4. Okay, you could do that, right? Or you could look at this as I got 3/5 times this whole expression here, right? And so what I could do is I could get rid of the 3/5 first, right? This is 3/5 times this whole thing, so I could divide by it on both sides. And then I'll just be left with 2x minus 4 and then simplify that way. Okay. So I'm going to choose that way. I don't want to distribute this through. I just feel like you get a lot of fractions that I don't want to deal with. So I see I have 3/5 times this whole thing. So what I can do is I can just divide by 3/5. Okay. And if I divide by 3/5 on one side, then I got to do it to the other side. Now, I want you to think about that for a second and think, well, did I change the problem at all? Right? I'm just simplifying down, right? So if I divide, whatever I do to one side of the problem, I got to do to the other side. So if I have 3/5 times this whole thing, right? If I just divide by 3/5 on one side, I'm allowed to divide by 3/5 on the other side, right? So then over here, now these cancel out. And you'll see in a second why I like doing it this way, right? And so what am I left with? I'm left with just 2x minus 4 equals, now I have 18 divided by 3 over 5. It's a good review for your fraction math. 2x minus 4 equals 18 over 1. And when you're dividing by a fraction, you are just multiplying by its reciprocal. So multiply by 5 over 3. Okay. Now 18 times 5 is 90. So you have 2x minus 4 equals, and when you multiply fractions again, you just multiply straight across. 18 times 5 is 90. 3 times 1 is just 3. Okay, so I can still simplify down a little bit more. I'm going to bring this up here just to have more room. 2x minus 4. Well, what's 90 divided by 3? It's just 30. Okay. And now this is something that we know how to do, right? We're just trying to isolate the variable, so I can add 4 on both sides. Get 2x equals 34. Divide by 2. And I get x equals 17. Again, I can always verify this by plugging it in, and when I want to plug in, I'm going to plug into my simplest equation. So I can plug it in there. But again, you could plug it in all the way back here. You're just going to have to deal with some fractions and stuff like that. But again, not that big of a deal. And that's the other nice thing about math, is that you can have different ways to solve the same problem. Okay. Another way you could look at this is you could distribute this in. You're going to see here in a second why that's a little ugly. Okay, so you have negative 4/5. I think most of you are going to pick the first way, but just in case, times 4a. And then you have a negative times a negative, which turns into a positive. So then you have positive 4/5 times 1. I'll just write it out. Plus 4/5 times 1 equals 28. Okay. Now, I can put 4a as a fraction, so I can put it over 1. I can put 1 as a fraction, make it 1 over 1. Right, so I have each one of these things here. See, it gets a little uglier here. But still not too bad. We can just multiply straight across. So you have negative 16a over 5 plus 4 times 1 is 4. 5 times 1 is 5 equals 28. Okay, now, again, now you have a couple different options you could do. You could either subtract 4/5 to the other side and deal with more fractions. At this point, I want to get rid of fractions because I just don't like this. It just seems like a lot of mess here. So if I multiply this whole side by 5, is that a legal move? Right, well, if I multiply this whole side by 5, I got to make sure I do it to the other side. Well, what happens if I do this? Right, well, this is going to have to be distributed in to both of these terms. Right, so I have 5 times negative 16a over 5. Well, those are just going to cancel out. And then I have 5 times this thing. So those are going to cancel out. So then you're just left with negative 16a plus 4 equals 28 times 5, which is 140. Okay, now we got rid of the fractions. Now we're in a place that looks a lot nicer. So I'm going to subtract 4 on both sides. And I'm left with, bring it over here, negative 16a. Let me make some more room. So negative 16a, so this goes up to here, equals 136. Divide by negative 16. And I get a equals negative 8.5. Okay, so A equals negative 8.5. It's kind of hard to read. Let me write it. Okay. So again, you have different ways of doing the same problem. Now, if this was me, I just wanted to show you both ways. What I would have done is multiply or divided everything over here by negative 4 over 5 and divided this side by negative 4 over 5. So then these cancel out. And you get 4a minus 1 equals, that would be, let me write this out. If 4a minus 1 equals 28 divided by negative 4 over 5. Does the same thing as multiplying by the reciprocal, so 28 times negative 5 over 4. This is 28 over 1, same thing, multiply straight across, and you get negative 140 over 4. Which is equal to negative 35. So then you can kind of come back and you go 4a minus 1 equals negative 35. And you can solve that from there. So two different ways of doing the exact same problem. This way to me seemed a little easier, but I wanted to show you both so you can just, whichever one you prefer. Okay, last problem here for the 1.2 notes. So you purchase 5 tickets to a football game from StubHub. The tax you pay is $2.50 per ticket. In addition, StubHub charges a convenience fee, which is $15. The total cost of your order is $325.50. What is the price per ticket? Okay, so got a lot of information here. Let's try to dissect some of this. Right. So what's the important information in this? Well, we got 5 tickets. That's probably pretty important. Right? We know how many tickets we bought. You pay $2.50 per ticket. Okay. Now, why am I emphasizing the per ticket part? Because we know that if you buy 5 tickets, then this is going to be $2.50 times 5. StubHub charges a convenience fee, which costs $15. Now, this is not $15 per ticket; it's just a flat rate of $15. And we know that the total cost here is $3.50, So kind of just underlined all the important stuff. So now let's see if we can write a little equation and see if we can solve how much it costs per ticket. Okay. So right off the bat, I know that our total is $3.50, So I'm going to write that on the right-hand side. 352.5. And we have a one-time fee of $15. So I'm going to have a plus 15, right? Now we have $2.50, a tax of $2.50 per ticket, and we have 5 tickets. So I can write this as 2.5 times 5. And we bought 5 tickets, but we need to know the cost of those 5 tickets. Right? Everything's in terms of cost. We have 5x plus this whole thing is going to equal $352.50. Now, if I wanted to read this back out loud, I got 5 tickets at some cost x that we don't know. Plus, I got to pay $2.50, so 2.5 for 5 tickets, plus a $15 convenience fee, and my total is going to be $352.50. So how many tickets how much did it cost for the tickets? So now we just got to simplify this down a little bit. Okay, this right here simplifies down to $12.50. So we have 5x plus 12.5 plus 15 equals 352.5. Oh, missed a number. Okay, And now from here, we can try to simplify down. We have a constant here and a constant here. Those can combine. So we have 5x, $12.50 plus $15 is $27.50. 27.5 equals 352.5. I can subtract the 27.50 on both sides. These cancel out. So I'm left with 5x equals 325. I'm going to bring this up here so we have some room. You can divide by 5 on both sides to get x alone. So x is $65. Okay. So again, when we looked at this problem is in terms of money, right? So x represents some amount of money times 5 of them, because we got 5 tickets, plus 5 times 250, because there's 250 for the tax, and we got 5 tickets, plus our flat rate of $15, and that has to total $352.50. When we simplify everything down, we figure out that x, the cost of the ticket, is $65 per ticket. So this here is the end of the 1.2 notes. Again, as always, if you have questions, please let us know. Send us an email. Come see us in Office Hours. It's good when you guys have questions. Other than that, I hope you guys have a great rest of your day. And let us know if you have questions. Bye.